Hi champion, today we want to solve question from probability, and of course the question is from the Ogun State 2024/2025 Unified Examination, the third term to be precise. So we have the question given on the board. A pair of a fair dice, like the plural of a die. A single die is just, when you have one, it's a die, and when it becomes two, we have it as dash. So each is numbered 1 to 6. As we all know, 1 to 6 is how a die have the numbers from 1 to 6. We have the numbers on the cube of a die. So this one could be 1, this could be 3, this could be 2, here could be 4, here could be 5, and at the base, we could have it as 6. So we have it as 2. So when they are tossed, they are asking us what's the probability of getting the sum that is at least 9. When they say at least 9, it means the minimum that we can generate from the two dice is 9. So what's the probability that we are going to have 9 or 10 or 11 or 12? There is no way two dice is going to produce 13. The maximum you can have is 6 and 6, and the addition of the two will result to 12. So what's the probability that when you toss the two dice, you are going to get at least 9, the minimum of 9. So it could be 9, it could be 10, 11, and 12. So before we proceed into solving this, there is something called outcome table. Like for the two dice, what is going to be the outcome for the permutation and combination of the two dice? So let's have it here. We have the first die. And what are the things we are expecting to be on the first die? We have 1, then 2, 3, 4, 5, and 6. Those are the numbers expected to be on the first die. At the same time, the second die has the same feature. So we have the second die here, the second die. For the second die, we also have 1, 2, 3, 4, 5, then finally the 6. So upon having the two outcomes that we can have on each die, we can throw 1 and 1. And when you throw 1 and 1, it results to 2. So this is going to result to 2. When you throw the first die to be 2, and the second one results to 1, 2 and 1 will result to 3. At the same time, if your first die is 3 and the second one is 1, the addition of the 2 will be 4. Of course, this is 5, 6, and 7. You will agree with me that if the first die is 1 and the second one is 2, so the sum of the 2 is going to result to 3, 4, we have 5, 6, 7, and 8. If the first die is 1 and the second die is 3, we have 4, 5, 6, 7, 8, and 9. So it goes on and on like that. The first die is 1 and the second one is 4. This is going to be 5, 6, 7, 8, 9, and 10. And once again, if the first die is 1 and the second one is 5, it's going to result to 6. This one, 1 and 5 is 7, 8, 9, 10, and 11. First one is 1, the second one is 6. This is going to be 6, 7, rather. We have 8, 9, 10, 11, and 12, which is the maximum figure you can get from two dice. That is when you draw 6 and 6, it will result to 12. Now back to the question, the probability of getting at least 9. So we are having probability of at least the minimum to be 9. And for probability, the formula for probability is the number of expected outcome all over the number of possible outcome. So if you are having a coin, for instance, coin has two sides, the edge and the tail. So the probability that you are going to have the edge is going to be, how many edge does it have? 1. And how many sides does it have? 2. So that is probability of getting 1 out of 2. So it will be 1 all over 2. So the probability of getting 1 from a die is always going to be 1 out of 6. Even the probability of getting 4 from a die. It's not 4 over 6. But how many 4 do we have on the die? Just 1 4. So that is going to be out of 6. So we are now being asked, what's the probability that we are going to get a number that at least the lowest value it could be is going to be 9. So we are going to circle out all the values that are 9 and above. So it means we can draw 3 and 6. It will give us 9. We can draw 4 and 5. It will give us 9. We can draw 5 and 4. It will give us 9. 6 and 3 will give us 9. That's just the minimum. You can go beyond that because the question was the minimum, at least 9. So at the same time, if you draw 5, 4, and 6, it will give you 10. So we have a work to do with that one too. 5 and 5 will give us 10. Then 6 and 4 will give us another 10. We can also have 11 because at least 9. So 11 is also part of what we are looking for. 5 and 6. Then we have 6 and 5. It's also possible. And once again, 6 and 6. We have 12. So here is indicating the expected outcome. What is the probability of having this kind of value? So in any way, or whatever way you want it to be, the probability of getting this one out of everything that is possible here. So we now count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you may count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are expecting to have 10 outcomes. From how many outcomes? From everything that is possible. It could be 1 and 1, it could be 2 and 1, it could be 3 and 1, and many more like that. So you count everything. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Of course, everything is going to be 36, 31, 32, 33, 34, 35, and 36. So we are expecting 10 expectation out of possibility of having 36 outcomes. So you may reduce this one to the lowest form. So we have 2 goes here, 5, and 2 goes here, 18. So we'll be left with 5 all over 18. Easy.